So our first problem in the warm-ups was x times the quantity x minus 2 equals 0. Does anybody think they know the solution to that? What'd you get on that, Vanessa? All right, so she's saying x equals 2 or x equals 0. We're going to see if she's correct. Here's a way that we can check this. I'd like you to go to your graphing calculator to see if this is correct. So a way we can check this is to go to y equals. And we've talked about this before, how we can put the left-hand side of this equation into our calculator. So put it in. And then we can put the right side of this equation into our calculator of 0. And we'll go ahead and do a zoom 6. Here's the way the left side looks. Here's the way the right side looks. And we're trying to find out where they're equal to each other. So that's going to be represented by the intersection point. So we go to second, trace, intersect. And we have to be pretty close to the intersection point, which we are. It's asking us, is the blue curve your first one? And we push enter to say yes. Is the red curve your second one? Push enter to say yes. One more time, and it tells us that the solution is going to be 0 as one of the answers. To find the other one, we do second, trace, calculate, intersect. We get over here close to our solution right here. And that's good. We're going to push enter to say yes. Whoops. Let's get back over there. Okay. Enter to say yes to the blue, yes to the red. One more time. And so 2 is going to be our other answer. So that means the x values that make this true are going to be x equals 0 and x equals 2. The way we do that is we just set each factor equal to 0 and we solve. Okay. Now, here's the thing, guys. We can only do that method of setting each factor equal to 0 when it's set equal to 0. If it's equal to any other number, that's not going to work. So let's say we say x times x minus 2 equals 8. You cannot just say, well, x has to be 8 or x minus 2 has to be 8 like we could back here. Does anybody know how you'd have to approach this problem? This is what you'd actually have to do. You'd have to distribute this through and get x squared minus 2x equals 8. The key is that if we're going to use factoring to solve a quadratic, it has to be equal to 0. So how can I get this equal to 0? Subtract 8. So now I'm going to have x squared minus 2x minus 8 equals 0. And now I'd have to factor this. And we look here first. What are the factors of x squared? X and x. To figure out what factors to use on the 8, see, we go here first, we go here second. We want to think, what are numbers that multiply to be 8, but subtract to be 2? 2 and 4, right? And in fact, when I check the outers, I get a 4x. The inners, I get a 2x. And I want those outers and inners to combine to give me a negative 2x. So how do I need the signs to go in order to get a negative 2x? A negative 4 and a positive 2, right? So that's going to be how that factors. I can double check it. X squared minus 4x plus 2x and minus negative 8. And so that is equivalent. It's all about being equivalent. And so now we're going to set each of the factors equal to 0. And so what would the solutions be here, you guys? Negative 2 and 4. That's minus. So the key on this is it has to be equal to 0. If it's not, you have to get it set equal to 0 and solve it. All right, anybody think they know the answer to this one? What'd you get, Audit? Oh, 2 answers. So did you do the square root of this side and the square root of this side? And anytime we have an equation and we take the square root, it is plus or minus 9. I saw a lot of people who just had 9. Go to y equals. Put in the left side of this equation, just x squared. Put in the right side of 81. Push graph. Here's y equals x squared. What am I going to have to do to be able to see the line y equals 81? Go to the window. I have to go higher on the y value than 81, so I'm going to go to 100. So here's our quadratic. Here's the y equals 81. Can you see there are 2 spots where it works? And if I just find one of those, I'm not going to find both, but just to show to you, this is the one that people typically forget, the one over here. I have to be close to it. I push enter, enter, enter one more time, and -9 is the solution to that. Okay? All right, guys, you need to bring up your notes. So to find the notes, you're going to go under Canvas. Go to Module. And the notes are right here under our Chapter 3 module. All right. So as you're getting that into your Google Drive, I'm just going to go over the learning goals. We want to be able to solve quadratic equations by graphing, which I just showed you. We're not going to do that much anymore. That's a good way to check. Also by using algebra methods such as factoring. We're also going to look at a real life problem. When you're solving a quadratic equation, they could tell you, hey, find the roots. That means the same thing as solving the quadratic. They could say, find the zeros, find the x-intercepts, find the solutions. All of those mean the same thing, solve the equation. A root of an equation is simply a solution. A 0 is going to be the x value for which f of x is equal to 0. The function is equal to 0. Graphing, we're going to talk about that a little bit later. I showed you on the calculator how you could do graphing. The big method we're going to use today is this one, using square roots. If we have an equation in the form u squared equals d, where u is an algebraic expression, we can solve by taking the square root of each side. So I can solve this by taking the square root here and the square root here. So the square root of u squared is just u. What did I say we have to put in front anytime we have an equation and we take a square root? Plus or minus. So this answer would be u equals plus or minus radical d. I can also solve by factoring, and I'm going to show you a shortcut way for doing this as long as the a does not equal something other than 1. If a is equal to 1, I have a really quick way to factor, but if a is something other than 1, then it doesn't work as well, and I'll show you another method for that later on. So as I said, we're going to be using square roots and factoring. We're going to solve this one by square roots. So go ahead and do that. Caleb, what's the answer? Good. And you could just write that as plus or minus 10. The second one is a little bit more challenging because notice we have a quantity getting squared, but it's in that form, u squared equals some value. So what I can do is take the square root, take the square root. The square root of something squared is just going to be the x plus 2. Over here, I have to put plus or minus 6. So now I have to say x plus 2 can be 6, or x plus 2 can be negative 6. And so now solving this, I'm going to get x could be 4, or x could be negative 8. I can check that. 4 plus 2 is 6. 6 squared is 36. Check this number. Negative 8 plus 2 is negative 6. Negative 6 squared is 36. Why is it, though, when I go to my calculator and I do negative 6 squared, why doesn't it say 36? You want me to put it in parentheses? Let's see. Negative 6 squared. Oh, now it works. So what is the calculator doing back here? Is it just like a big mistake or what? Why would it say negative 36 here but positive 36 here? Yeah. Good. Harper's right. What it's doing here is it's actually doing 6 squared because it always does exponents first, and then it thinks it's times negative 1. So it's following order of operations. It's doing it right. So if we want the whole quantity of negative 6 to get squared, it has to be in parentheses. Just keep that in mind. If you ever want to square a negative, you have to use parentheses. All right, example 1. If A and B are expressions and A times B equals 0, then either A is 0 or B is 0. That is the zero product property. It only works if two numbers multiply to be 0. Here we have two expressions that are multiplying to be 0. What that tells us is either 2x minus 5 must be 0 or x plus 1 must be 0. So go ahead and solve that. Samira, do you have it? Okay. Caleb, do you have it? Mm-hmm. 2.5, -1. Good. So if we solve this, we're going to add 5, and then we're going to divide by 2, and that's 5 halves, or you can say 2.5. And this one, we just subtracted 1. Did you guys get it now? Okay. All right, guys. So on this one, we had two expressions that were multiplying to be 0. So I was allowed to set these equal to 0 and solve it. Add 5, divide by 2. But here, these are not multiplying to be 0. And so the first thing I have to do is get it set equal to 0. So, Isabel, what am I going to have to do then? Right. So we're going to have to add 10 in order to get it set equal to 0. Now, I'm going to set up double parentheses because I want to get this into two factors. So I look here first and I say, what are the factors of x squared? X and x. Now I can look here. We want numbers that multiply to be 10. Look at this sign, just reading it backwards. Multiply to be 10 and add to be 7. Numbers that multiply to be 10 are 1 and 10, 2 and 5. Which ones add to be 7? 2 and 5. And in fact, I want them to add so that I can get a negative 7. So what do I want the signs to be for that to happen? Both negative. And so now because I have two numbers that are two values that are multiplying to be 0, either x minus 2 must be 0 or x minus 5 must be 0. Solve it. So our solution is 2 or 5. Okay? All right. First thing I do, I look and I say, okay, can I take square roots? No. Next question is it equal to 0? Yes. So now I want to try factoring. But when I only have 2 terms, a common method is looking for a GCF, a greatest common factor. What is the common factor here for these 2 terms? X. So I'm going to factor out an X. What am I left with if I do X squared divided by X? What is that? Just X plus, what's 8X divided by X? Just 8. So now I've got this. If this had been a constant, like 2, 3, 4, 5, 6, 7, I could divide by it, but it's a variable, so I cannot divide by it. In fact, I have to set X equal to 0 and X plus 8 equal to 0. So now I've got my solutions are 0 and what else? -8. Those are the 2 solutions. Any questions? All right, let's go to the next part. So these are practice problems. You can always solve using any method, but we want to solve using the best method. Do you see how we have this quantity squared? When we have this quantity squared, it means we're probably going to use square roots. So I want to get this all by itself so I can square root it. So what does that mean I'm going to do? Helen, how can I start getting this by itself? Yep, I'm going to subtract 1 from both sides. I want to get this by itself. This quantity squared is not quite by itself. So Caden, what can I do next? Divide by 3. Yep, so I'm going to divide this side by 3 and this side by 3. So now I have x minus 4 quantity squared equals 9. So now I have this quantity squared by itself. So now's the time to take the square root. I can take the square root here, take the square root here. I have x minus 4 equals plus or minus 3. So I'm now going to have to do 2 problems. X minus 4 can equal positive 3, or x minus 4 can equal negative 3. Finish that. Patrick, what'd you get? 7. Good. 7 or 1 is correct. All right, number 2. This looks like it's going to be something where we can take the square root. We'll have to see what happens. All right, so what are we going to do first to make this work? I want to get the piece squareds together. So what could I do? Subtract, good. Somebody whispered that. So I'm going to subtract 5/7 p squared from both sides. So 1/7 minus 5/7 is -4/7 p squared equals -20. How do I get rid of, well, first of all, let's get rid of the negatives. Can't I just divide both sides by -1? Sure, let's do it. So now they're going to be positive. I'm just going to make them positive like this. Okay. How can I get rid of the 4/7? Multiply by what? 7/4. So I'm going to multiply both sides by 7/4. When you're multiplying, you can just multiply straight across. So 20 times 7 is 140, and now I have to divide by 4. Guys, I don't know 140 divided by 4, but I know 140 divided by 2. What's that? 7. And now divide by 2 again, and what do you get? 35. If you want to divide by 4, just divide by 2 twice. because 4 is 2 times 2. Okay, that's an easy way to simplify. So now I'm going to have p squared equals 35. Before I go too much further, though, here's another way you could have done this. What's 20 divided by 4 times 7? See how you can do it that way too? All right, take the square root now. I have to use plus or minus. Does the square root of 35 simplify? No, so we just have to leave it. Square root of 35. That's our answer. Nothing more we can do with it. Questions? All right. Let's have you guys try number 3 on your own. I will be doing it up here, but try not to look up until you're finished, okay? Does anyone have negative x squared plus 14x minus 40? Did you go take it to the other side? If you did, just multiply through by -1 if you don't want that to be a negative there. Just multiply the whole equation by -1. You're allowed to do that. You can multiply by any number or divide by any number. Okay, so hopefully you're to this point. We say, what are the factors of x squared? X and x. Now we look here. What are the factors of 40? In other words, what are numbers that multiply to be 40, read it backwards, add to be 14? What are they, you guys? 10 and 4. And in fact, we want them to add to be a negative 14. So what do I want the signs to be? Negative. And now can you tell me the solutions? 4 and 10, right? Anybody get that on their own? Good. A couple did. I know I went through it kind of fast. Okay, guys, on this problem, number 4, again, we want to get it all set equal to 0. And the reason why is because I can't do square roots. If I could, I would, but can't do it. So I'm going to add 3x to both sides, and I'm going to subtract 60. So these cancel out. I just have 0. Over here, I have 3x squared. I have negative 6x plus 3x. Well, that's minus 3x. The 60 doesn't have any like terms, so it's just minus 60. If you have an equation, you are allowed to multiply or divide by any number. Number being key, not variables. You can't divide or multiply by x, but you can multiply or divide by any constant. So what can all of these be divided by? So just do that. Now we set up our double parentheses. Factors of x squared are x and x. Read it backwards. Numbers that multiply to be 20, subtract to be 1. Because the coefficient here is 1. Multiply to be 20, subtract to be 1. What are they? 5 and 4. And in fact, with this 5 and this 4, I want to end up getting a negative 1x. What do I need the signs to be in order to get a negative 1x? Right, negative 5, positive 4. So what are our final solutions then when we think what minus 5 is 0 and what plus 4 is 0? 5 and negative 4. Okay, hopefully factoring seems a little easier now than it did in Algebra 1. Okay? All right, number 5. Find the zeros. Find the zeros of the function. Here's our function. What am I setting equal to 0, x or y? Y. So I'm setting this equal to 0. So just when factoring was getting easier, remember I said it's getting easier, right? We throw this in, this coefficient in front of x squared. I can no longer use that method of multiply to be 4, add to be 12. It's not going to work. But we can still do this. We set up our double parentheses. What are the factors of 9x squared? 3x and 3x. Typically, we use the ones closest together. It just seems like it usually works that way. If it doesn't, then you go back and you change it. What are the factors of 4? 2 and 2. Now I have to check. I do get 9x squared and I do get 4, but I have to check those outers, 6x, and inners, 6x. What I want to get is a 12x. So what do I want the signs to be to make it happen? Positive, positive. And so now I have to say 3x plus 2 equals 0. I don't have to do it twice. Subtract 2, subtract 2. 3x is negative 2, and x is negative 2/3. Okay, I did that kind of fast. We're going to check our work. Go to y equals. Type in this function right here. Type in 9x squared plus 12x plus 4. Push your zoom 6. Let's get a standard screen. Here's the way it looks. We think this solution is negative 2/3. Watch how I can check. Second trace, calculate a value. Sorry, I'm hitting the wrong keys. When x is negative 2 divided by 3, that's how I put in negative 2/3. Negative 2 divided by 3. We have to use the negative 2 divided by 3. Push enter. We get 0. So we did it right. Sometimes people think it's negative 3/2. Oh, no, that was wrong, wasn't it? See what I mean? Okay. What does that point happen to be, that negative 2/3, you guys? What is that kind of point? It is the vertex. Good. It's also what else? Not y-intercept, but x-intercept. Yeah. All right, guys, last thing here. It says number 5, but it's number 6. A skydiver drops out of an airplane that is flying at an altitude of 4,624 feet. Is more or less than a mile high? More? Some people say more, some less. How many feet are in a mile? Nice. 5,280. Yeah. So a little less than a mile in the air. Sounds terrifying to me. Use this formula right here to write an equation that gives the skydiver's height h in feet during free fall, t seconds after the skydiver drops out of the airplane. You're going to use this formula on your homework, okay? This formula is used all the time in physics and all kinds of different maths. So here's our formula. This is the height. So the height at any given time is negative 16t squared, but we have to plug in for this value. This represents the height at time 0. What is that skydiver's height at time 0 before he does anything? 4,624, right? It's that easy to get our equation. We just plug in our original, remember h sub 0 can be thought of as original height, height at time 0, plug it in, okay? Is it possible for the skydiver to wait 18 seconds before pulling the parachute forward? I'm going to give you 1 minute with your partner to answer yes or no. Let's just take a guess though. How many people say yes, that'll work? Okay, we got about 3 people. How many people say no, it's not going to work? Oh, more people say no. Let's see. Work it out with your partner. All right, so what we're saying here is find h of 18. Find the height at 18 seconds. Does anybody get that height? What'd you get over there, Aaron?
Negative.
Ooh, is that good or bad for the skydiver? Very bad. What does that mean? He would be where? Below ground, yes. Not good at all. Did you guys just type that into your calculator and then look at the table? That's what I did, but you could also just plug in 18 and evaluate it. Not good. After how many seconds did he actually hit the ground? 17, but hopefully he pushed his cord somewhere around here, right? This might be a good spot or here. I don't know exactly how high up you should be before you do that. I really have no interest in knowing that answer either. I'm not interested in skydiving. But anyway, let's find and interpret h of 1 and minus h of 2. So h of 1 minus h of 2, what does that mean we would do? What are we plugging in? Time of 1, can I do that on my calculator? Right there it is. 5608, or sorry, 4608 minus h of 2, 4560. So that is how far? 48 feet, right? So we found the answer, but what does that really mean? What does that answer mean? Anybody know what it means in terms of, yeah, what do you think? Awesome. I love it. So 40 feet, 48 feet traveled between 1 and 2 seconds. And I'm sure that's important information. You know, you kind of want to know, where you are and when you should, have the parachute cord going and everything else. All right. Any questions over this? So what are you going to try first when you're solving an equation? Just taking the what of both sides. Square root if you can, right? That's one of our good methods. And if you cannot do that, then you need to get a set equal to 0. And then you can try factoring. All right, guys, good job.